So we're going to talk about secant and cosecant here. Secant, again, just replace with secant here, same bx minus c plus d. This has the same period as sine and cosine, so it's 2 pi over b, the absolute value of b again. So if you don't have that written down for the other one, so it's 2 pi over the absolute value of b. The asymptotes are actually exactly the same as tangent. Again, why would it have an asymptote? Because we're dividing by cosine, which tangent is sine over cosine, so we have the same thing. So if you don't remember what tangents asymptotes were, that was bx minus c is equal to both positive and negative pi over 2. And that's where your vertical asymptotes would be. So those are the key formulas, and also knowing that it has a period of that. So let's go ahead and just kind of look at the secant graph. We're going to plot it together on this next slide. So when we do the secant graph, I'm going to think about the cosine graph. So I'm just going to graph cosine. So remember, cosine starts at 1, goes to 0, goes to -1, and goes back. So this is my cosine graph, which is what that looks like. So this is the cosine of x. Now, if you think about it, where is that 0 is where I have asymptotes. So wherever I get a 0 value is going to be my asymptotes of this secant graph. And all we're going to do is, since it's the reciprocal, we're flipping these values upside down. So we're saying, hey, what's 1 divided by 1? Well, in a secant graph, 1 divided by 1 is 1. And then we do 1 divided by really smaller numbers, these ones between 0 and 1, which actually makes it extremely big. It makes it go up fast, fast, fast. And as you approach 0, it goes up extremely fast. So it ends up being this, like that, and kind of going like this, kind of like a parabola. Same with this, -1 divided by -1 is -1, and it will keep going down like this. And then same here, graph will kind of look like this within those asymptotes. These asymptotes continue over and over again, and this kind of oscillates back and forth over and over and over again. So I would highly suggest checking out Desmos by typing in both the secant of x with red, and then doing the cosine of x in blue, just to see how it looks. So the cosecant, very similar again, that is 1 divided by sine, so therefore it'll be very similar to cotangent. So it has the same asymptotes as cotangent, which is bx minus c is 0, and bx minus c is pi. That's how I find the first two. And as you can see, we'll actually have a lot of asymptotes where you just can multiply by integers. There's a ton of them. We only like to draw 2 of them. Same period as sine, cosine. Tangent is the only one that has a different period. So let's look at our example 3, which will be graphing cosecant of 3x times -3 over 2. So I do an XY table, so I do x, we're going to figure out those x values, and I'm going to plug them in. We're going to only have to draw 3 consecutive asymptotes. They're pretty easy to find, I'll show you, and then plot 2 points, 1 on each side of the second asymptote. So the middle asymptote is what it's saying. So let's go ahead and find the asymptotes. So if you remember, cosecant is 1 over sine. So we're going to have bx minus c, which is the 3x, and set it equal to 0. Also, the 3x is equal to pi. So when you get that, we get x is 0 as an asymptote, and x is equal to pi over 3 as my next asymptote. Again, we're dividing by sign, so it's the bx minus c equals 0, or the bx minus c equals pi. In this case, the bx minus c is inside of the cosecant, which is the 3x. So that's where we get that. And we just have to graph those. So at 0, we have a vertical asymptote. And at pi over 3, which it's harder to see where pi over 3 is in here because we have pi over 4, pi over 2, 3/4 is pi. So if you think about this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. We're breaking it apart into 12ths. And 1/3 of 12 is 4. So we have 1, 2, 3, 4 tick marks. So this right here would be your next asymptote. So that's at pi over 3, and that is at x equals pi over 3, and this is at x equals 0. So those are the equations. Like on a homework assignment, you don't have to write those down, but you just have to graph them. But like on a test or a quiz, I would expect you to like actually write the name of the equation just to see what you're actually doing, because you might have made a mistake, and then I'll give you points for this, but if you put it wrongly, I would take away points. So again, there are 12 dashes between 0 and pi, so 1/3 of that is actually 4 of those, hence where I got that. So the asymptotes will repeat every 4 in this case, 1, 2, 3, 4. So we're going to go 4 more, and this will be my next asymptote, which is actually at, if we think about it, we want 0 to pi over 3. We added pi over 3 and add another one, which is 2 pi over 3. So this next one is at x equals 2 pi over 3, because the period will be the same for this. And you can do pi divided by your b value. So pi divided by 3 is, in fact, pi over 3. So every pi over 3, we keep adding on to that. So if you find one asymptote, you can just keep adding pi over 3 or whatever the period is. Now, all we have to do is find the middles of these, which is actually pretty simple. You can actually see it. Sometimes it's harder to see. That's the middle, that's the middle. So we have pi over 2 is the middle, but where is this one if you didn't know? Well, remember it's broken into 12 pieces. So we could have 1/12, 2/12, which is a pi over 6. Or if you wanted to take pi over 3 plus 0 and divide it by 2, which is also pi over 6. So either way, there's a couple ways to find that. So it's pi over 6, and then we have pi over 2 for the other one. We're going to substitute those into the function and see or evaluate what those are, and then we can rough sketch our graph and figure that out. So I'm going to rewrite down the equations right here, and then I'm going to substitute in those values of pi over 6 and pi over 2 here. So when I plug that in, I get, let's see, it'd be pi over 2. So cosecant of pi over 2, if you think about it, it's the sine of pi over 2, but we think it flipped. So the sine of pi over 2 is in fact 1. So 1 over 1 is in fact 1. So this becomes 1, and 1 times this turns into negative 3 over 2. 1 times negative 3 over 2. So again, this is 1, just as a heads up. Just check it out. This one is, let's see, 3 pi over 2, which is going to be negative 1 in this case. So it'd be negative 1 times that. So it gives us a positive 3/2. So we will plot those. So the first one at this thing here, we're going to have negative 3/2 right here. And then the other one is right here. So then if we click the graph button, this is actually going to mimic each other like this. And it's going to look like this. They will always kind of look like that. And then if we wanted to add another one, we could always add more if you wanted to. So you don't have to do this, but just notice that it will always repeat over and over and over again. So if I plotted the middle there, it would go like this. So again, it will always oscillate and repeat over and over and over again. So let's go ahead and graph a secant one. They look identical to cosecant, it's just slid left to right. Just like sine and cosine, they're identical, except slid left to right. It's just shifted over by pi over 2, or depending on what you did to the function, it's just shifted left to right. So the first thing is finding the asymptotes, which remember, secant is 1 over cosine, so where is cosine 0? Well, that's at pi over 2 and negative pi over 2. So we take our inside and set it equal to both positive and negative pi over 2. So let's do that. So we have this bx minus c. There's no minus c in this case, it's 0. So it's just 3/2 x is equal to plus and minus pi over 2. And then we would multiply by 2/3, or you multiply by 2 and then divide by 3 if you want to think of it that way. So therefore we get our asymptotes. If you multiply by 2, the 2's cancel. And then you divide by 3, which will be plus or minus pi over 3 in this case. So in this case, we have pi over 3, which we'll look for that on this graph. And we'll think about it. We have 1, 2, 3, 4, 5, 6 spaces. And we want 1/3. So 1/3 of 6 is 2, so pi over 3 is right here. So this is where positive pi over 3 will be. So x equals pi over 3. Now to find where the next asymptote is pretty easy. We have both positive and negative pi over 3. So we're just looking at, we have negative pi over 3 for an asymptote and positive pi over 3 as an asymptote. How far apart of that is that? So the idea is we have this, and then we could subtract the difference of these and make it absolute value, which gives us actually 2. So it's 2 pi over 3 apart from each other, which is actually half of the period. So the period would be, we take the 2 pi divided by this, and that would give it, and then half the period is actually where the asymptotes are. So that's because it will oscillate down, up, and I will show you that in just a second. But the idea is we would add 2 pi over 3 to this. So to get to the next one, we have to add 2 pi over 3, so plus 2 pi over 3, which will give us pi. So our next asymptote is at pi, so x equals pi is the next asymptote. Then we would add 2 pi over 3 again to get 5 pi over 3. So the idea is when we have this, we can keep moving. So we have 1, 2, 3, 4 in this case. Go 1, 2, 3, 4. We can put another asymptote right there. So 4 away. So let's put this last one, which is actually adding that pi plus 2 pi over 3, which is, in fact, 5 pi over 3, I believe. So it'll be 3/3 plus 2/3 is 5 pi over 3. So that is equal to my next asymptote. Now, all we have to do is plug in the middles of those, and maybe it's hard to figure out what those are. One way to find the middle of this is think about this. This is pi over 3. This is pi. We add those pi plus pi over 3, and then divide it by 2. So to figure out that, let me just move this over a little bit so that you can see where I do that. I do pi plus pi over 3. And divide all of that by 2 to give us that x value that I wanted to plug in, which is in fact 2/3 pi. The next one is pi plus 5 pi over 3, the two asymptotes, and divided by 2 to find the middle of it. It's the average of them, which will give us 4 pi over 3. Those are the middles of those. So if you didn't know that, that's how I found the middle of those. I just took this value plus this value, put them together and divide it by 2 to cut it in half to find the middle. Same with this. Find this value, add them together, divide by 2. Again, you can add these together in your calculator without the pi symbol, and then take the pi symbol back on later. So let me move this back so we can see this stuff. So let's just substitute those in. Negative 1/3 secant of 3 over 2 times that, and negative 1/3 secant of 3 over 2 times that again. So we're substituting in those x values of 2 pi over 3 and 4 pi over 3, and we should get a value for that. Just notice that this becomes pi, the secant of pi, which is what is the cosine of pi, which is in fact 1. 1 times negative 1/3 is in fact positive 1/3. Sorry, this is a negative 1 here. Cosine of pi is negative 1. That is the x value is negative 1 at that point. So then we get a positive 1/3 here. And this will be, let's see, 12 over 6. So 2 pi, which gives us a positive 1. 1 times negative 1/3 is negative 1/3. So we just plot those 2 points and then just kind of rough sketch the graph. So in the middle here, we get negative 1/3, which is somewhere around here on your Alex. You'll have to type in the coordinates this and this, and this and this to do the thirds correctly. Otherwise, rough sketching it looks pretty good like this. And that's our final thing for graphing trigonometric functions.